So in the today's class, we'll discuss one of the important questions concerned to exam point of view, that is 5 marks question from chapter number 2, that is Karnoff's map. In short, we call that as K-map. This is question number 27 in your annual exams for 5 marks. So it is K-map. Again, it looks like a truth table, but the way of solving the expression is, a simplifying expression is different method. That's why that is called as Karnoff map. That was, this map was developed by a person called as Karnoff. So that's why we call it as Karnoff map or K-map. Again, this Karnoff map also starts with the same thing what we have learned in case of truth table. That is, before starting the K-map, first you can check out the given Boolean expression. Once you check the Boolean expression, then you come to know that how many number of variables are there in that. Depending on the number of variables, we have the K-map series. That is the K-map for 2 variables, K-map for 3 variables, and K-map for 4 variables. But normally, for exam point of view, they are going to ask, maximum time they are asked only for 4 variables for 5 marks question. So first we start with an expression. Assume that has only 2 variables. A and B are the only 2 variables. If there are only 2 variables, then how to prepare a Karnoff map for 2 variables? First we check it. So if the number of variables are 2 means, we know the general form, same thing we will continue here also. That is, we are learning in case of truth table, that is 2 power n. 2 power n, where n is nothing but the number of variables. If I take number of variables as 2, then the expression becomes 2 square, where n equal to 2, then that is nothing but 2 into 2, that is equal to 4. It means these 4 squares we need here. In case of truth table, we are calculating the same formula, but we are saying that number of rows will be decided. But in case of Karnoff's map, we are deciding number of squares present in the K-map. Depends on number of variables. So assume that A and B are the 2 variables. Then, for these 2 variables, you want to write the general form of the K-map. 2 variable K-map. Number of variables are 2 variables. A and B are the 2 variables. If there are 2 variables, then we know the general form, that is 2 power n. Substitute the value of n here. N is equal to 2 here. Number of variables is 2. So substitute the value of n as 2 here. That is 2 square. That is equal to 2 into 2. That is equal to 4. What is this 4? This is 4 squares we get. The 4 squares are required to represent 2 variable K-map. Then once we know the number of squares present in that K-map, then you can write it. A K-map that looks like this. 2 variable K-map. 2 variables, how many squares I need? Means 4 squares. 4 squares. Then write this line. A and B are the assumed variables here. So if A and B are the two variables, then first variable you can use it for row purpose, and second variable you can use it for column representation. So I write A, B, B. Even I mentioned here. This side A, this side B. This is the step 1 in this schema. It means first you can check out how many number of variables are there in the given expression or a function. Then you decide how many squares are needed to solve that particular function. Then draw so many squares. The next step, you have to represent the squares. You have to mark the squares. And also you can go with this column headings and row headings are represented by using binary values. If it is a two variable, I can say that it is a binary values. So first one I will represent 0, second one is 1. Right? Here also I represent 0 and 1. So according to SOP method, in the K-map, we know SOP that we have solved examples also. In SOP, if the value of the variable is 0, then it should be complemented. So here also we will follow the same rule. If the value of the variable is taking the variable, its value is 0, so it should be complemented. Next, A, second row, its value is 1 is given, so it's a normal variable. In the same way, column also can mark it. That is, B is there, its value is given as 0, so according to SOP method, it should be complemented. The next one is value is 1, so it is a normal variable. This is step number 2. I represented rows and columns with the variables, with and without barred or complemented. Then, next step, you have to mark the squares. Each square we are marking with the help of designations that already learned in the form of M0, M1, M2, like that. You know that designations. So that can be written in each square at the bottom right, like this will write. Right? I'll separate that. So here I'll mark it as 0. Right? If you want, you can write this, or else you can leave also these boxes. But representation is required. So 0, 1, sorry, 0 and 1. Then this is 2, this is 3. 0, 1, 2, and 3. These are the markings for each squares. Then, once it is marked, then we are in SOP method. So, according to SOP method, SOP means that is going to give us the mean terms. Mean terms. What is mean term? We know. That is, product of all the literals is nothing but a mean terms. So, based on that, I represent the mean term in each square. It means according to SOP method, each square in the K-map represents mean terms. In every square, we are going to write the mean terms. So, what is mean term? Product of all the letters. So, based on that, row multiplies the column here, that generates the mean term for this particular square. So, if I take the 0th square, then the mean term for this is, this will call it as general form also, general form of K-map for two variables. There is A complement, right? A complement and multiplied the column, that is B complement. A complement dot B complement, you can write, or else you understood that nothing that is dot only. So A complement, B complement is the first main term we have written for this zero definition, that is square 1. Like this, you can generate the main term for this square. It is labeled as designation 1. So again, row multiplies the column. So row is A complement, then column is B. A complement B is the second main term we have generated. This is about first row, and follow same procedure for second row also here. So in the second row, designation number 2 square has row is A and column is B complement. So A B complement is the main term for the definition 2. And the last one, main term is A B. A B is the main term of this last square designated as 3. So this is the general form of two variable K-map. In this, we learn how to judge the number of squares required for solving the function or a problem, then how to represent that row side and column side, then how to mark that as barred and unbarred. Then we have learned how to represent each square with the help of a designations. Then we have generated the min terms for each square. This is about two variable K-map. And in the same way, we can proceed with three variable K-map also. If the variables, what I'll assume is, if it is a three variable K-map, then I'll take A, B, and C as three variables. So I'm taking A, B, and C, and then it has three variables. It means n equal to 3, number of variables equal to 3. Then substitute that in the general form 2 power n, that is equal to 2q, that is equal to 2 into 2 into 2, that is equal to 2 to the 4, 4 to the 8. So 8 squares are required to represent this K-map. Then the next thing is how to prepare a K-map for 8 squares. So 8 squares K-map, they are given in a particular format here. You cannot write as you wish, right? So for 3 variables, you can remember that only 2 variables and 4 columns diagram is required to represent this 3 variable K-map. We should not write 4 rows into 2 columns. It is invariant, not a K-map. Try to understand this. This is very important here. How to draw the 8 squares. For 2 variables, we are not worrying because it's equal. 2 rows, 2 columns. But in case of 3 variables, we should follow the Carnot's math method, that is 2 rows and 4 columns. So 2 rows, 8 columns. You draw now. Two rows are there. Now make it 4 columns. First column, second column, third column, and fourth. This is the way you have to represent a 3 variable K-map. Not like this. You should not write like this. Right? 1, 2, 3, 4. Number of squares are 8 only. But this is the wrong way to represent a K-map. In a 3 variable K-map, we need 2 rows and 4 columns only. This is wrong method. If you follow this, this is not a K-map. So 2 rows and 4 columns. So 2 rows, 4 columns. So in this, the variables are 3, A, B, C. Then how to represent rows and columns? The first variable, you can take it for representing rows, and remaining 2, you can use it for representing columns. For that, I write it as A, then this side BC, 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 and BC. Here then, first variable is representing rows, and remaining 2 variables are representing for columns. Now, use binary numbers to represent these variables values. So first we'll take as 0 for the first row and 1 for the second row. The value of this variable is this one. 1. Like this, for columns also you can write. Here there are only 1 variable. I use single digit binary number, 1 bit binary number to represent different set of values for these. Whereas for representing columns, I have to follow again binary numbers, but there are 2 variables, so I should use 2-bit binary numbers. So 2-bit binary numbers to represent 2 variables, that is 0, 1, 2, 3. But in binary, the 2-bit binary values from 0 to 3 are 0, 0. Writing like this 0, 0, 0, 1, 1, 0, 1, 1. These are binary numbers from 0 to 3 by using 2-bit. But we are not following this technique in our K-map because Carnot has given a separate representation. Then only that becomes a Carnot map or K-map. That is, has shown us we are using even though binary numbers, but he named that particular technique as a gray code. What he has used to represent a 2-bit binary numbers, the Carnot has used a gray code representation if they are exceeding more than 2. If it might be a 3 variable K-map or 4 variable K-map, we are using Carnot's gray code to represent the rows and columns. That gray code is nothing but like this. You can write it. Keep this 0, 0 as it is. 0, 1 also same thing, but only these last 2 values is replaced. Each and every combination must have its complements, different values. Based on that, he has given a gray code that is 1, 1 you can write, then 1, 0. This is called gray code. The first one is a normal binary numbers to represent the variables, but slightly changed and called as a gray code. By using gray code, we are going to represent the rows and columns which have 2 or 3 variables. Normally a 2 variable rows and columns. So based on this, now I am writing a gray code for the column represented, that is B and C are there, B into C. So I represent 0, 0 is the first value, first set of values. Then second one is 0, 1. So 0, 1 is the second column, and 1, 1 is the third column, and last one 1, 0. 1, 0. This representation I call it as gray coding. Even though we are using binary numbers, but representation is differing in last 2 values. Either that may be a column or even row also. We come to know about this in the 4 variable K-map. Clear, right? That contains rows also 4, columns also 4. At that time, we will follow the same method of gray coding. Then, to mark the squares, There also we are following the gray coding technique only. That is, you can mark this first square as 0, second one 1. Now, what I say is, if the last button column or in this case last button column is there, so jump, I use the term as jump so that you can understand that. Right? Gray code ಹೆಂಗ್ ಬರೀಬೇಕು ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಬಂದಾಗ ಆ ಕಾಲಮ್ ನ ಜಂಪ್ ಮಾಡಿ ಮುಂದೆ ಹೋಗಿ ಹಿಂದೆ ಬನ್ನಿ. You have to jump and write the next value. 0, 1, jump and write 2, come back and write 2. This is the way we are having a gray codes. That is 0, 1, 3, 2 is there. So what I am representing here, to keep in our mind, 0, 1 to the last column, jump, go to the last column, mention that designation, then come back and write the next designations. So 0, 1, 3 to this representation we are calling it as gray code representation. Next, in the second row also we can do the same, but follow the same method of jumping. That is, after 3, the next one is 4, then this is 5. So again, here is last column, jump, and then the next one 5 is here, this is 6, then come back and get this 7. These are designations. Here also we are following gray code technique. Then, what this is now, the last step is you have to generate the min terms for each and every square here. So how to generate min terms? Simple, the product of all the literals. So row variable multiplied to the column. But one thing you have to here, mark it now, because we have to generate the min terms. So wherever variable is 0, it should be complemented. Here also, both the two variables b and c, both the values b value is 0, c value is also 0, both are complemented. B complement, c complement. And the next one, 0 means first variable is b, second variable is c, first variable b value is 0, which is complemented. Next is 1, keep it as is. In this case, both are 1, 1, b and c, so no need to complement. So last one, if you observe, 1, 0 is there, b value is 1, c value is 0, so c will be complemented. Now, you can write the min term for each squares. This square is front of these two, row multiplied with the column. So a complement, then column is b complement and c complement. This is the min term for representing 0. And for this, a complement, b complement, c. A complement, b complement, c. And next, for this square, a complement, b, c. So a complement, b, c. And for the last, a complement, this a complement row is common for all. Only column we are adding. A complement is common. If you do a complement, b complement, we are finding the same row. So a complement, b and c complement. These first 4 squares are ready now. Therefore, the min terms. Like that, we can generate the min term for remaining 4 squares also. Now, a is there for all the squares we have a common, then columns should be added. So a, b complement, c complement. And next one, a, b complement, c. Next one, a, b, c, a, b, c. And next one, a, b, c complement, a, b, c complement. So this is the way you write for 3 variable K-map. This is called a 3 variable K-map general form. Because question is not given, only you assume some variables, then you have generated the 3 variable K-map. In the same way, you can go with a 4 variable K-map. Same technique, 4 variable K-map. If it is a 4 variable schema, now and assume that A, B, C, and D are the 4 variables. Assume one. A, B, C, D are the 4 variables. So n equal to 4. If n equal to 4, 2 power n equal to 2 power 4 equal to 2 multiplied 4 times. What will get? 2 into 2, 4. 4 into 8. 8 into 2, 16. 16 squares are required to solve the particular function. Now, 16 squares are there. This is very easy because 4 rows, 4 columns will get 16. So, draw that 4 rows, 4 columns. So 4 rows, 4 columns. So first row, second row, third row, and fourth row. One, two, three, 4 rows. And you can make it 4 columns. First column, second column, third column, and fourth column. Right? So 4 rows, 4 columns. Then assumed variables are A, B, C, D. So A, B, C, D. So A, B, C, D means first 2 variables. Listen to the method now. This is very important because such type of questions are normally asked in your exam for 5 marks. If there are 4 variables A, B, C, D, then first 2 variables you can take it for row representation, remaining 2 for column representation. It means according to this example, assume example A, B. So A, B represents row and C, D. The C, D represents for columns. So write it. First, what I write is A, B, A, B, A, B, and A, B. For these columns also write it as C, D, C, D, C, D, and C. Then write the gray code to this. As you use when 3 variables can have this gray codings. For each and every variable you are writing. The gray coding is 2 variables, so you write in 2 bits that is 0, 0. Then this is 0, 1. This is 1, 1. And last one is 1, 0. In the same way, this is 0, 0, 0, 1, 1, 1, 1, 0. Gray coding is represented. Then, according to the gray code values, you can mark the variables complemented in normal variable. We are in SOP method, so what you can do is, if the value of the variables are 0, they are complemented. The first case, if the 0, 0 are there, A, B is there, so both are complemented. A complement, B complement, because the values are 0, 0. So in the same way, 0, 1, first variable is 0, so A is complemented. Then 1, 1, no need to complement normal variables. Last one, 1, 0 is there, so second value is 0, so B will be complemented. Like this here also, 0, 0, both the variables are complemented. 0, 1, so first variable is complemented. 1, 1, no need to complement. 1, 0, second variable is complemented. So these representations are 4 representation for rows and columns. We have completed. Now you can write the designation for each squares. In the same way, how you learn in case of that 3 variables, 4 columns were represented by using gray coding system, only can write it. So start with 0, 1, last button column, jump, 2, come back, 3. You remember this 0, 1, last button column, and if you go for a jump, go and write the next number, and come back and write designation number. Next one, after 3, you can write as 4, 5, that column jump, 6, 7. Now here also, in case of columns, we have jumped and hidden down. Here also in the row side also, this is the last but one row. So that's why here also we are jumping now. 7 is over here. Next number is 8. That's representing with the jump the next so last, go to the last row and continue that. 7 is 8, 9, last column, jump, 10, come back, 11. Now, continue the previous row, that is just like what we have done in the column, we are doing the row also. 11 is here, so 12, 13, back column, jump, 14, and 15. This is very important step in case of 4 variable K-map. If you remember, the marking of each square, the representation of each square designation is very important here. If you do this correctly, then the solving the problem is very easy for you. If you are unable to represent the designation, then it's very difficult for you. Straight I can say that you may not get even a single marks out of 5 marks if you forget this, how to represent the designations in each squares. Once these designations are represented, then now the last step is you have to generate the min term for each and every square. That is, if it is a 0th designation column, then A complement, B complement, C complement, D complement. Product of all the details is the min term. So A complement, B complement, then C complement, D complement. This is first min term like that. Next one is A complement, B complement, B for these are common for all, and C complement, D. And for this row, this is common, so you can only go on changing this. So A complement, B complement, C D, A complement, B complement, C D complement. This is the first one. Like this, you can generate the min term for each and every square in this 4 variable K. So next one is A complement, B. This is over. Now C complement, D complement, C complement, D complement. A complement B is common for this complete row, so only can change is C complement D. So A complement B, C D, then A complement B, C D complement is second here. Like that, third and fourth. A B multiply with different column labelings. A B is common for complete row, so A B, C complement D complement, A B, C complement D, then A B, C D, then A B, C D complement. And last row, A B complement is common for all the squares. Remaining we can write down the columns. So A B complement, C complement, D complement, A B complement, C complement D, A B complement, C D. So A B complement, C D complement. So this is the way you represent the 4 variables K map. This is the general form of 4 variable K map.